Hi everyone. In this video, I'm going to solve a challenging question coming from the Cambridge A-Levels complex numbers, which appeared in the May June 2015 sessions of paper 31, and this is specifically question number 8. And just like this, guys, I keep on posting challenging questions that have been appeared in the Cambridge examinations in the past years. So if you haven't checked my other videos for different topics, please just go ahead and look into the description of this video. You will be able to find links of all the challenging questions per chapter wise. Now let me show you what is the first general comment made by the examiner in the examiner report. So even the very able candidates struggled answering the questions of 8 part 2 and 8 part 3. So the first part of this question is pretty simple, but part 2 and part 3 were proven to be the most challenging, where part 3 is the one where students struggle the most. So over here in part 2 and part 3, both the questions requires visual understanding of the complex numbers. So basically based on the given question, if you're able to visualize what's really happening by drawing a complex diagram, that is the Argand diagram, and then if you're able to plot this kind of things, then it might be a bit easier for you to solve. But guess what? For part 3 of this question, in spite of drawing the Argand diagram, a lot of people were not able to solve it. So yes, let's get started and try to answer all the questions one by one. So in the main question, they have given us a complex number W, which is in this specific format. And in the first part of this question, we are asked to convert the given format of W in this format. And in doing so, we are not supposed to use a calculator, which means that I'll need to show all the necessary steps that leads me to that particular format. Now, this question is pretty self-explanatory. So in case if you're having any kind of doubts, let me know in the comments. I'll be very happy to help you with that. But for now, let's move on to the second part. It is given that p is a real number such that the argument of the complex number w plus p is always going to lie in between pi by 4 and 3 pi by 4 inclusively. And now we are asked to find the set of possible values of p. This is for 3 marks, and if you haven't given an attempt to this question already, it's time to test your knowledge that based on your current understanding of complex numbers, if you are able to solve this question or not. So pause the video over here, come back once your solution is ready. So welcome back, guys. If you did give it an attempt, let me show you what is the correct answer for this part, and then I'll also show you what are the examiner comments based on this question. So the values of p that are valid will always be in between -6 to 2. How, I'll explain that in a while for the students who are not able to get it. But for the students who got this correct, many congratulations. Your complex number ideas, specifically on the arguments of a complex number, is pretty solid. And here is the comment made by the examiner for this part. They mentioned that it was very rare to see correct solutions for this one, which basically indicates two things. The first one is either a lot of students weren't even able to understand the question, so simply they couldn't attempt it. The second one could be that a lot of students might took an approach, but then because there were a lot of different kind of varieties of incorrect methods, it was very hard for examiners to point out any specific approach which was very common and incorrect by the students. And that is why you should be really very proud about yourself if you are able to solve this question completely by yourself. But yeah, for the students who did not get it correct, it's completely fine. I am over here to explain that. So over here we are having the solution. Let me take this to the right side. Okay, so first let me take you towards the question and try to understand the question in a proper way, because I believe 80% of the question is solved right over there once you understand it properly. So it is given to us that there is a p which is a real number, and if we add that p to the complex number w which is already given to us over here, we'll have altogether a new complex number. And then if we find the argument of that new complex number, the minimum argument of that complex number will be pi by 4, and the maximum value of the argument of that complex number will be 3 pi by 4. And then it can have all the arguments in between pi by 4 to 3 pi by 4. So what are all the possible values of p such that this can happen? Now see, I can understand a lot of students can become blank right over here. But what is the correct approach whenever you go blank in this kind of questions in the examination? The first step is to write down all the things that are already given to you in a way that your brain can understand and process in a better way. After that, if it's possible for you to draw some kind of a rough diagram to understand the situation, go ahead, do it. Most of the times, if your preparation is right enough, you will be able to crack this kind of difficult questions. But yeah, let me show you how I'll do this one. The first thing I've done is I've just assumed that my p is equal to x over here because p is a real number. So I've just assumed that it is equal to x, which is a real number. And then I found out what is the new complex number w plus p. Because p is a real number, I am just going to add that x to the real part of the w, that is 2. That is how I get 2 plus x being the real part of the new complex number and 4i being the imaginary part of the given complex number. So I can see that only real part is going to be a variable. My imaginary part is staying constant as it is. So 4i is not changing at all. So now if I have to draw a rough diagram over here to understand what's really happening. So here is my Argand plane with my real axis over here and my imaginary axis over here. My 4i is a constant value. So let me mark 4i over here. Now, where could be pi by 4? Pi by 4 is 45 degrees. It is going to be somewhere over here. Where will be 135 degrees? 135 is 3 pi by 4 basically. It is going to be exactly 90 degrees away from here. That is in the second quadrant. So this is my 3 pi by 4. This is my pi by 4. So there will be a complex number sitting over here. And when the complex number is sitting over here in my Argand plane, that is the minimum value of the argument of the complex number, that is pi by 4. And then when the same complex number will be over here, that is the maximum possible argument that I am having over here of 3 pi by 4. Now I have to find what are all the possible values of the p, which is a real number, such that I can find out this range of complex numbers. So that let's say even if I'm in between somewhere over here, my 4i is a constant. That is why I'm not marking anywhere on the y-axis apart from 4i. So my complex number could be over here, it could be over here, it could be over here. Basically, it can be anywhere on this line. So the idea over here is that how am I supposed to find that what is the least possible value over here and the maximum possible value over here on the real axis, so that I can get the values of p that always lies in between them. And in order to achieve this, I have drawn two separate scenarios. The first scenario is when I am talking about this complex number where I am having the minimum value of the argument, which is pi by 4. And in the second scenario, I am talking about the maximum possible value of the argument, which is 3 pi by 4. And I know that I can find out the argument of any given complex number if I do tan inverse of the imaginary part over the real part. And that's this angle that we find over here from the positive real axis. So for the first scenario, I am able to see that the value of x that I am achieving is 2. And on the right hand side in the second scenario, the value of the x that I am achieving is minus 6. So this simply indicates that whenever the value of the p will lie in between minus 6 and 2, I will be able to get a complex number whose minimum argument will be pi by 4 and the maximum value is 3 pi by 4. When the value of x is minus 6, I am at this location. And when the value of x is equals to 2, I am at this location. And therefore, any values in between this p minus 6 to 2, I can get all the kind of places in between them. And hence, I can say that the final answer for this question is going to be such that the value of p lies in between minus 6 and 2. So yes, that's how you solve the second part. Now let's move on to the third part of this question. We are having a complex conjugate of w, which will be 2 minus 4i, represented by w star. Now this complex number w and w star in the Argand diagram are called as points s and t respectively. Now we have to find in the form of modulus of z minus a is equals to k the equation of a circle passing from the points s, t and the origin. So yes, give it an attempt over here if you haven't already as usual and come back once you are ready. So welcome back if you did give it an attempt. Over here is the examiner comments for the third part, that this was the most challenging part of the question. Why am I saying this? Because in the examiner report they had mentioned that even over here for this part, in spite of drawing the Argand diagram, only few were able to solve the whole question correctly. In part 2, there were basically either no attempts or maybe a lot of different incorrect attempts by different students. But for part 3, in spite of drawing an Argand diagram for a rough idea, people were still not able to solve this completely. Now let's see how we can solve this. So from the information given to us in the question that the circle passes from the point S, point T and also the origin. That is what I have drawn a rough circle over here. And I know that the center of the circle is at point A and also the radius of the circle is going to be K. So over here I know that because this circle is passing from the origin, this is called as a radius. This part is called as the radius. So radius of the circle is equal to the distance from the origin to the A, which is A itself. And that is why I can say that the radius, which was K, is just equal to x. If you are able to crack this, then it's going to be very easy to solve after this. But yeah, this was the most difficult part for students to crack. That in spite of having the diagram, they were not able to see that A is your radius itself. So yes, once that I know that A is my radius, I can simply find that value of A by taking the distance between the 2 points. And I know that this distance between the 2 points is given by x2 minus x1 square plus y2 minus y1 square is equals to the distance square. And that is the formula that I've implemented over here. The x coordinate of this point is A, the y coordinate is 0. So 2 minus a square plus 4 minus 0 square is equals to the distance between the 2 points square, which is a square. And once you solve this, you will be getting the value of a is equal to 5. And because a is equal to k, the final solution will become that z minus 5 is equals to 5. So yes, that's how you solve this question. So thank you so much guys for watching this video. In case of any kind of doubts, you can let me know in the comments. And here is my WhatsApp number. You can contact me for any one-to-one private classes that you would like to have in order to boost your grade. Thank you so much.